Okay, you guys, so this video is going to help you interpret some of the data that we have collected with the lab. This is what you should have come up with as far as positive reactions. So whenever we do see a precipitant form, and then the negative represents we see no reaction because no precipitant is forming, no insoluble product is made. If you do want to screenshot this, you can use it later or just hit pause and double check my data to yours. But then that tells us whenever we're writing in our reactions, we'll be writing in a reaction for A1, 2, 3, 5, and 6. And again here for B1, 5, and then 6. Okay, and then go on and C, we have none. For D, we would be writing one for D1, D5, D6. For E, we have none, and then for F, F1, F5, and F6. So I am going to just show you, if you've done everything up to this point, you have written those reactions. Now, I went ahead and have what I want you to add to it on this one in particular. I will go through one here in a second with you, but all you did yesterday is you just wrote the reaction. I want you to go back in and add the states of matter. So in other words, you're finding what the precipitant is, okay? And you've got to write that in as a solid. So in this case, you should find that silver hydroxide is your precipitant. And then, again, you've already watched the video for net ionics and how to do those for the precipitant forming reactions. And this is what I want to see, okay? So you are going to give the charge, say it's aqueous at first, which it is, but then the precipitant comes out as a solid. So I'm going to go through this one with you. At this point, you have already written down A2. Hopefully you in chronological order like I asked, and you wrote down A2. You wrote this much down from yesterday. And the rest of your sheet should already be filled out like that. Okay, I don't have mine filled out because I don't want you to see all the answers. But this one we will go through together. So the first step is we need to write in the states of matter. And we already know that they began as aqueous, so you don't need to take time to look that up. The big question is which of these two is the precipitant forming one? So you're using your reference sheet to do that. And let's look at the chloride first. So when I look at this and I find my chloride, chloride with my silver, it says low soluble. So that's going to be my clue that it's insoluble. I'm very sure that that will be my solid forming one. Okay, now it should be that only one of them is solid forming, but just do a double check to make sure we didn't do something screwy with writing the products. It'll be a nice double check. So I'm looking for sodium nitrate. So I want to find nitrate first, and anything combined with nitrate is soluble. So I want to mimic that. Okay, now we don't have to draw it out to show what's going on as long as we understand how to separate this out. So I know that my net ionic, I need to show that that's my end result, and I'm just showing how that's created. A lot of times with these, I start with the product, and then I split it up, and if I end up needing more than one of those, I have to represent that as well. In this case, I don't, but we have a silver with a +1 charge. I would want to show that it's aqueous combined with a chlorine with a -1 charge. And again, that started off as aqueous. Now, just like I showed you in the notes in one of those lessons, if I did need, like, let's say this was Ag2Cl, then I would need to put a coefficient of 2 up here. Or if it was AgCl2, same thing, I would want to put a coefficient of 2 up here. I don't do it as a subscript over on the ion side. It would be a coefficient, just like what the notes showed. So that's what you're going to be doing for the rest of these. You're going to be adding the states of matter, and then you're going to write the net ionic for that one that was insoluble. So for every one of these, at least one should show up as insoluble. I'm also going to show you, and I'm going to use this as my example, which means you guys cannot use this one as your example. But I'm going to show you how you would fill out this part here. So it's telling you in this last part, go back and just choose, and you're not going to be allowed to choose the one that I am, but choose one of the wells, and we want you to actually draw it out to write the complete ionic reaction, so the complete double replacement reactions. We'll end up circling the spectator ions, and then we'll put that down arrow to show which ones are falling out in solution. We might changes directions a little bit. I don't know if we really have to circle those. I don't know if I like that, to be honest with you. So I'm going to show you how I'd like for you to do this. And I'm going to use, which again makes you not be allowed to, but I'm going to use this A2 reaction as my example. You're going to pick any other reaction here. So the well, I would write in A2, and then I'm literally just going to copy over this double replacement reaction, okay, just as I see it here. So AgNO3, start off aqueous, it reacted with sodium chloride. It made silver chloride, that was my precipitant, and then it made sodium nitrate. Okay, so that's what we mean by writing the complete, you know, maybe it would be better if this would say double reaction or double replacement. Okay. Then here's where I don't know if I don't want us to do this, where it says circle the spectator ions and put a down arrow. Let's just do what we're used to doing. Okay, so let's actually mark that part out. But the picture part is what I'm very interested in. So I want this to mimic what you saw in the notes. And you only have to do one. You don't have to do it for all these. You're just getting to pick one to demonstrate that you know what you're doing. So we know that we begin with, you know, silver's floating around here. We have nitrates floating around. We have sodiums floating around. And we have chlorines floating around. What I want you to do is somehow show, and if you had to write more than one, if you pick something that's not a 1-to-1 ratio, show how those fall down into the solution, just like what we did in our notes. And right down here, we end up with AgCl. Okay, so drawing that picture. All right, then you're going to actually pick one where we are going to show a double replacement, but where it really doesn't happen. So what does that mean? Because you haven't written any of these. You're actually going to go back into here and pick any of your no reactions, any of your negatives. I'm going to pick this one, which means you guys cannot. So I'm going to write AgNO3, and actually, never mind, because I don't like how it's with NO3 here. How about I pick, so ignore that. I'm going to pick this one instead. Okay, so CuNO3 reacting with NaBr. That's the one I'm going to do. All right, so let me put that in. What well was that? Well, that was well, I kind of crossed it out now, but that was well B3. You guys are not allowed to do B3. And I would actually encourage you to stay away from this column. Why? Because it's like NO3 reacting with NO3. It's just kind of, honestly, it's dumb. So whenever you do this one, steer away from this column. Pick anything in any of the rest of the columns, but steer away from the sodium nitrate column. Okay, so I'm going to do copper 2 nitrate. And the only thing that makes me irritated whenever I printed mine is I wish I would have paid attention, it split. And that was well B3 for me. So you're not allowed to do B3 on your own notes. Sorry, did not realize it wasn't showing up there, guys. And it reacted with what again? Your teacher's memory is failing here. Sodium bromide, okay. Now these truly did start off as aqueous, so I'm going to mimic that. But the important thing and the easy thing to some degree is we get no reaction. So we are going to show that, no reaction. Why? Because they're all aqueous. It's boring, nothing happens. But let's draw out what that means here. So I'm going to take this concept and I'm going to draw my beaker of what is actually occurring. So I have this beaker, and in here I have, it looked like it was copper 2. So I want to show that. So I have copper 2. I have nitrate. I need to remember that you got to be able to see it, or what's the point? I have sodium in here, and then I have bromine or bromide. And that's it. Nothing falls out. Nothing combines together. There is no cloudiness. There's nothing that is going to layer out on the bottom of the speaker. But it's still important. You know, they're all soluble. They're all going to stay in that ionic solution and in an aqueous form. Okay, so that talks you through how to do that. So then really you're at the point where you can finish this. It's not due, I don't think, until next Wednesday. We want to give you a little time because it is going to be a little intense with filling everything out and keeping up with everything else. But we want you to begin to work on this. And this will be due, like I said, next Wednesday. So we will wrap it up. You guys have a good rest of your day.